Welcome to the section 7.2 notes. No warm-up question today. We're going to jump straight into the law of signs with the ambiguous case. I'm going to tell you right now, these notes are probably going to be a little bit longer, so this video is going to be a little bit longer. This is what I think is probably the hardest section of the entire class that we've done up to this point. There's a lot of little areas that you can make mistakes on, so this is going to be a tough section. So if you're given two angles, then there's always one unique triangle formed. But in this lesson, we are going to be extending the law of signs to solve for triangles where we're given two sides in an opposite angle. So basically, in this type of situation, there's not always one unique triangle. There might be two. This is called the ambiguous case. So ambiguous just means that it's unclear. So if I give you two sides and an angle, giving you side-side angle, it is unclear if we are talking about an acute or an obtuse triangle, essentially. It's unclear if we're talking about a very specific triangle or a few different. So anytime you are given side-side angle, you need to check for the ambiguous case. Otherwise, you are neglecting an entire triangle that could have existed. So the reason why there's multiple triangles that could exist, okay, if I give you side length A1, side length B, and angle A, the first triangle that you could have could be this obtuse triangle right there. And then without changing that angle A measurement at all, okay, that's still the angle A, I could have gone all the way over here to get, that would be side C, would be a very, very long side C that I would not have really thought about. Okay, if you notice here in the middle, that would be an isosceles triangle. So as we're doing these questions, we always have to make sure that we check for the ambiguous case. Notice it says sometimes there could be two. That's because sometimes there could be only one, and sometimes there could be none. Here's an example of when there would not be a triangle, even though we are given two sides and an angle. Okay, if I give you side length A and side length B and angle A is rigid. Side B is rigid. Side A is rigid. So I can't move this. I could extend it out however far I want to, but there's that gap, meaning I don't have a triangle. So to figure that out, there's a few different ways to determine whether we have no triangles, one triangle, or two triangles. So when we're given this ambiguous case, we have to determine how many triangles are possible. This is how. This is a breakdown of how in one nice convenient place. They're not exactly the easiest of things in the world to remember. And the reason why I said this chapter or this section's harder is because these are all variables. Like lowercase a, lowercase b, capital A are all variables. And depending on the problem, you might be plugging in for angle A, but it's a C in the problem. So you have to really understand where these variables are coming from and how to use them. So if you have an acute angle A, so if angle A is less than 90 degrees, and also side length A is shorter than side length B, and then this is what's going to tell you if you have two triangles, one triangle, or no triangles. Okay, we're just going to go through a couple of examples for each of these things right here. So the way that I remember this stuff, if I remember right now, first off, I'm comparing A to the same thing in all of these. If I have A is greater than, that's the bigger of the things, so I get two triangles. If it's equal to, in general, I only ever have one triangle, so I'll say equal is one triangle. And then if I have less than, that's smaller. Smaller than one would be no triangles. That's how I remember it. You might come up with your own specific way, but for this first one, we see that we have an acute angle, and A is definitely less than B, so I need to compare compare that to 12 times sine of 26. When you're doing this chapter, make sure you have your calculator in the correct mode. We are in degrees, so that brings me to 8 compared to, I don't really actually care exactly what 12 sine of 26 is. It's 5 point something, so I know that this is greater than, and because it's greater than, I have two triangles. And then in this next example, I'm going to be comparing 8 to 16 sine 30 because I have an acute angle I have A is smaller than B. Well, I know what sine 30 is. I know sine of 30 degrees is going to be 1/2. So I have 8 equals 8. So that means there is one triangle. And only one triangle. And then the next one, still an acute triangle, or acute angle A. A is still smaller than B. But A compared to 12 sine of 76. 12 sine 76 is going to be 11.6 something or another. So that is going to be, I wrote 12. Should have put an A. A was 8. I put the B value. So A, 8 is going to be less than 11.6. So that leads to no such triangle. So no triangle exists, something like that. So you're going to be using this slide when we do examples 1, 2, and 6. This one is the easiest of the 3 sections, I guess. If you have an acute angle A and side A is bigger than side B, then you have one triangle. There's not really any work to go through on this. It's just you have one specific triangle. That's going to be example 4. Now, if you have side lengths A and B with an obtuse or a right angle A, if A is greater than B, there's exactly one triangle. If A is less than, I'm going to say less than or equal to B, there are no triangles. So let's see that. Well, in this first one, that's just straight up one triangle. That one's easy because it follows that A is greater than B. We have an obtuse angle. That's it. This is the one where I had to put the or equals to part, because if I draw this angle out, I'll say 120 degrees. It's an obtuse angle. So this is A. Doesn't really matter which one you put B at. I'll put B right there. And I'll put C right there. Figuring it's ABC for a triangle. I know side B, which is opposite of angle B, is a 6. Which means since A is also 6, I need to get from here to B with a 6. But that is not possible because of this obtuse angle. This is basically goes back to our triangle inequality. Okay? It's not going to work. It cannot get there because at best, at the shallowest angle, C can get all the way to A. But once you start increasing the angle, it's going to get further and further away from B. It's not going to work because of that 120 degree angle. So there is no triangle in this case, and similarly, there's no triangle here because A is strictly less than B. These are examples 3 and 5. Now is where we get to have the fun. Now we actually have to figure things out. So, in general, the first thing you should do on all of these problems is sketch a picture. Okay, I'd have angle A is 30 degrees. I'll put A right here. There's 30 degrees. I'll put B and a C. I always sketch a triangle, but I'm not guaranteed to always have a triangle. So I have an acute angle A. A is less than B, so that's the very first section of rules that I tried. So I'm going to be comparing 2 to 6 times sine of 30. Well, 2 is less than, because sine of 30 is going to be 1/2 times 6 is 3. So this tells me no triangle exists, or no such triangle, or something like that. That's it. That's the end of the problem. That's the whole thing. Okay, solve each triangle if possible. If there's no triangle that has these measurements, that is not possible. So I move on to the next one. And this is one where we have a whole bunch of issues. So again, draw a picture to start with. I have triangle KMN. This is like triangle ABC. So little k is like little a, little m is like little b, and big K is like big A. So going back to use those previous slides when you want to plug things in. So I'm going to start by drawing a picture. There's triangle KMN. I have angle K is 35 degrees. Side K is 9.1. Little m is 12, and then little n is just little n. And that's what I need to figure out, okay? I need to figure out all these other things. But before I can just jump in and start solving this triangle, I need to identify, okay, I have side angle. So there's a joke out there about side angle, and if you're not checking the ambiguous case, then you are a side angle. but maybe backwards or something along those lines. You guys can piece together that joke. So I need to check for the ambiguous case. I need to see if I have only one triangle or two triangles or possibly no triangles. So because I have an acute angle and A is less than B, using the variables from that slide, I'm going to want to compare 9.1 to 12 times sine of 35. 12 times sine of 35 is going to be 6.88 something or another, which means this is greater than that, so that tells me I have two triangles. Okay, so I already have one of my triangles drawn. I need to draw another one. So I need to kind of think about what can change and what can't change. Well, this angle K can't change, so I can draw angle K. That's still 35 degrees. Maybe the length of this thing changes. This is still going to be 12. The distance from K to N is still going to be 12. That's not changing at all. So I'm going to go back and I'm going to erase that line just because I have stroke erase on. This is going to be a shorter angle or a shorter segment than what I had last time, what I had drawn last time. So I'm going to put it out to here and I'm going to connect to there. Now this triangle looks very, very similar to the one that we already had, but it's a little bit different. So to signify that it's different, I'm going to make all of these prime. What I mean by that is I write K prime, K with an apostrophe, M with an apostrophe, N with an apostrophe. If you don't write K with an apostrophe, that's fine, because K and angle K prime have to be identical. But I need to have M prime, N prime, and N prime to differentiate between the two triangles, because we have two different possible values. So I'm going to do this one first and this one second. Doesn't matter which one you do first or second, but kind of it's up to you. So for this first one, I'm going to start by using our regular old law of sines. Sine K over K is equal to sine of M over M is equal to sine of N over N. I'm going to use just this first part. Sine of K, even though it looks like sync, sine of K tells me that I have sine of 35 over 9.1 is equal to sine of M over 12. To figure out sine of M, I multiply both sides by 12. That gives me sine M. To figure out what M is, I take the sine inverse of both sides. Now this is something that you're going to want to store in your calculator. So to store it in your calculator, what you're going to do is you're going to hit the button that says STO with an arrow on it like this, and then you're going to pick a letter. So I would use the alpha button and then I'm going to pick M because I'm finding angle M, and that's the division key. The reason we want to do that is because while we're going to round our angles to the nearest tenth and our side lengths to the nearest hundredth, I don't want to use rounded values when I'm solving the rest of the problem. So I'm going to be able to store this in my calculator to save a specific value. So when in my calculator, I hit sine inverse 12 sine 35 divided by 9.1. Make sure your parentheses are all in the right spot. You're going to get that M is about 49.1 degrees. It's 49.144742277. I'm going to literally hit that button that says STO with an arrow. That means store, the alpha key, and then find the calculator that I'm using. It's got green for the alpha. The button color matches the letters above the keys. I'm going to store that value in for M. So in this first triangle, we figured out that angle M is 49.1 degrees. If I want to figure out angle N, that's 180 minus 35 degrees minus M. Again, notice I'm using just M instead of 49.1. What that's going to allow me to do is get a more accurate answer. So I'm going to take 180 minus 35 minus, now to use the M, I again just press alpha and that division key in this case to get M. That'll give me 95.9 degrees. So I found this angle, I found that angle. In order to get that 95 degrees, 95.9 degrees, I had to use this angle. Now I still have to figure out what side length n is. So I'm going to go back to sine of k, which is 35. So sine of 35 over 9.1 is equal to now sine of n over, in this case, I'm going to have little n. Now, I have n rounded here. I'm going to do the same thing where I store that value into the n letter. So I can now get little n times sine of 35 is equal to 9.1 sine of n. And I don't have to worry about writing all these decimals out. I can keep that variable. So little n is equal to 9.1 sine of n over sine of 35. So in my calculator, I can do 9.1 times sine alpha button n divided by sine of 35. Rounded to 2 decimal places, it's 15.78. And we're only halfway done with the problem. That's why these problems are going to seem a lot more difficult, because all we did is we solved this first triangle. But now we have another triangle. We have this other triangle. Luckily, this is going to go a little bit faster, because in order to find m prime, all we have to do is take 180 minus m. We already have m stored in our calculator, so m prime is just going to be 180 minus alpha m. That's going to be 130.85, gives me about 0.9 degrees. I'm now going to store this value in for m. Okay, you can use a different variable if you want to, but I'm done using the old problem here, this green part. So I figured out what m prime is. To figure out n prime, all right, that's 180 minus 35 minus m prime. So 180 minus 35 minus alpha m is 14.1 degree, approximately. And then I can store this as my new n value. So when I go through this last step we did to figure out n prime, it's the same setup. So I can actually just jump to little n equals 9.1 sine of n, but both of these should be prime over sine of 35. And what's really, really nice, depending on how much work you've done in your calculator, you should already have this exact thing configured in your calculator history. You can just go back and hit re-enter, and it'll recalculate since we've now changed what the n variable has been stored as in your calculator. But otherwise, you'll take 9.1 times sine of n divided by sine of 35. We'll get little n prime is about 3.88. We didn't have a label for measurement, so I'll just leave it as 3.88. And you can put units, inches, feet, whatever. So for this one problem, you have 6 answers, because you found 2 angles and a side in 2 different triangles, and you had to identify that there were 2 different triangles. So these problems can get out of control very, very quickly. Now that being said, that doesn't mean they're all going to be that ridiculous, because if we look at this next one, we have an obtuse triangle. And since we have that angle A, we look at A compared to B. 21, let's try that again. 21 is less than 32, so there's no triangle. So we did all that work in this problem, and we come back in step number 3 and take hardly any time at all. Because remember, if you have an obtuse angle and A is less than B, you get no triangle. That is right here. See examples 3 and 5. No triangles are possible. On number 4, this time we've got angle C is what's given to us. So I'm going to draw my picture first. So 47 degrees, that's angle C. Little c is 20. Little a is going to be 12. So I'm going to put big A right there, put 12 right there, and that means this is going to be B. We have an acute triangle, or acute angle. but I don't compare A to B like it says in those theorems, definitions or whatever, because my letters are different now. This is like my A, the C is like my A in that theorem. So if I go back up, we have an acute angle, so I got to go to this one right here, but A is greater than or equal to B. In our case, C is 20 and A is 12. I compare C greater than or equal to 12. That is true. That gives me one triangle. That's example 4, which is one we are on. So now to figure this one out, I know that there's one triangle after saying acute with C greater than A. So I'm going to use my law of sines. Sine of A over A is equal to sine of B over B is equal to the sine of C over C. I know some of these values already, so I'm going to start by finding angle A first because I know nothing about angle B right now. So sine of angle A over 12 is equal to sine of angle C, which is sine of 47, over 20, which means sine of A is equal to 12 sine 47 over 20. So angle A is equal to the sine inverse of 12 sine of 47 over 20. Now, you could have simplified this before we took the sine inverse. The reason I didn't is because I know some of us are going to want to simplify that 47. That is a degree measurement. It is inside the sine. It cannot be simplified with these numbers outside. And then it doesn't really help us at all because I'm going to be using my calculator anyway. So I'm going to take sine inverse of 12 sine 47 divided by 20. Make sure you have all your parentheses in the right spot. And then again, I can store this, and since I'm finding angle A, I'm going to store it to alpha A. Since it's an angle, we're going to go to the nearest tenth. That's going to be 26.0 degrees. And as I've stored this to A, to figure out B, I can take 180 minus A minus 47 because there's only 180 degrees in a triangle. So minus 180 minus alpha A minus 47 tells me that B is about 107.0 degrees. It's 106.97. We'll round to 107 degrees. So I found two of my angles. I need to find one more side. So I'm going to take sine of B. So I have that in my calculator right now. I can store that to alpha B. Over my B value, which we don't know, is equal to, I'm going to use sine of 47 over 20. I'm going to be using this 26 value pretty much regardless, but I just feel more comfortable using these numbers because they're given to me. So 20 sine B equals B sine of 47. If we cross multiply, divide both sides by sine of 47. That gives me that little b is 20 times sine of B over sine of 47. So 20 sine alpha B divided by sine of 47. That's going to be, well, helps if you hit the division key. I missed a button. That's going to be about 26.16. Depending on the labels, you would have inches or feet or what have you. So number 5, we have an obtuse triangle or an obtuse angle. I keep saying triangle. It's going to give us an obtuse triangle because of the angle C is 97. Because I'm given angle C, I'm going to be comparing this one to that one. So I'm going to be saying that since C is greater than A, 45 is greater than 39, we have one triangle. So I'm going to draw my picture. This is going to be C with 97. Across from 97 degrees is 45. And then A and B, really doesn't ultimately matter where you put it. I'm going to put A right there, B right there. I know that sine of 97 over 45 is equal to sine of A over 39. That's our law of sines. So I can say that 39 times sine of 97 over 45 is equal to sine of A. So I can say angle A measurement is equal to sine inverse of 39 times sine of 97 over 45, which I can store in my calculator after I get that A is approximately equal to 59.3397, so it's going to be about 59.3 degrees. So I found angle A. I'm now going to store that to A. To find angle B, that's 180 minus A minus 97, which tells us that B is approximately equal to 23.7 degrees. And then I'll take sine of A over B, sine of A over B. I'm losing my mind. Sine of B over B is equal to sine of 97 over 45. I'm looking at my notes off to the side, and I got all jumbled up. So cross multiply, you'll get 45 sine B is equal to B sine 97. Divide both sides by sine of 97. To get your little b value, which since I've stored what angle B is in my calculator, I now just take 45 sine of B divided by sine of 97. To get little b is about 18.19. Again, we would have labels of inches or what have you. Now it's important that you are using this store feature, because if you do not and you round these values at the beginning and only put in 23.7 for sine of B, you are going to be off by a couple hundredths, a couple thousandths when you're finding the length of your side. So make sure that you do not mess up and round early, because if you round early, the rest of your answers are going to be wrong from there on out. All right, and number 6, I'm going to draw a triangle first. I have angle A with 32 degrees. So I'll start just like this. There's angle A. Across from A is 7. I'm going to put B right here. Across from that is 10. And there's C. So because we have an acute angle, we are going to compare 7 to 10 times sine of 32. No matter, I mean, we used A, B, and A like it did in the theorem, but we put the thing on the left that matches the letter for the angle. So since A was on the left, A was on the left because we have angle A. If we were given angle B, we would have put 10 on the left. But if I take 10 times sine of 32, that's going to give me 5 point something. So I get 7 is greater than 5.2, blah, blah, blah. I don't care what that number actually is. I just care that this gives me 2 triangles again. So I already have the first one drawn. I'm going to go ahead and draw this second one too. The AC part can't really change. That's still 10. There's still 32 degrees. All that changed was where angle B ends up. This is still 7 away. So there's still little c and little c. Now again, I have to make sure that I denote these with primes to make sure that I know I'm talking about the right thing. So I'm going to do this one first and this one second. So for that first triangle, I know that we have 32 degrees for angle A, so sine of 32 over 7 is equal to, I need to find sine of B first because I have the B value side. Okay, I wrote B, I should have just written 10 right away. So sine of B is equal to 10 sine of 32 over 7. So B is equal to the sine inverse of 10 sine 32 over 7. I jumped from here to here really quick. All I did was rewrite this sine of b equals on the left side in my head, and then I'm taking the sine inverse of both sides. Kind of smush those two steps together, so I apologize on that. I'm going to store that in my calculator when I find it. So sine inverse of 10 sine 32, parenthesis around that 32, divided by 7. Store that value in for b right away, but b is approximately 49.2 degrees. All right, make sure that you are identifying the fact that we're going to the nearest tenth, and I'm saying this is approximately equal to. I think the book made a note that said that they're just going to write an equal sign, but know that it's approximately equal to. I think it's probably just the person who was typing out the book got lazy. I don't really know. But I figured out what b is. So c is just 180 minus b minus my a value, which was 32. So 180 minus alpha b minus 32 is about 98.8 degrees when I round to the nearest tenth. To figure this thing out, after I store this to c, I now have to use sine of 32 over 7 is equal to sine of c over little c. Again, make sure you are not rounding or using a rounded value in here. You are storing this value we just found. So I'll have c times sine of 32 is equal to 7 times sine of c. I know when I'm doing my work, sometimes it's hard to tell the difference between a lowercase and a capital C, so just do your best. Know the capital always goes with that trig function. So little c, if I divide both sides by sine of 32, is going to be equal to 7 times sine of c divided by sine of 32. So little c is approximately equal to, this is where we use our alpha button. Little c is approximately 13.05 inches, feet, miles, yards, whatever that label is. That's the first triangle. To figure out that second triangle, my b value, my b prime, is 180 minus b. So to figure out what that b value is, I have it stored in my calculator still. I take 180 minus alpha b. That gives me 130.8 degrees, rounded to the nearest tenth. Store this as your new b value. Your c prime is 180 minus b prime minus 32. So c prime is approximately 17.2 degrees. So I've got those two. Now I need to find little c, which again, I can just jump right to there. Little c prime is 7 sine of c prime over sine 32. Since I've stored everything to this point, oops, I pressed the wrong button. So stored, see, since I've stored everything at this point, I can just go and hit 7 times sine of c divided by sine of 32 without having to press a whole bunch of buttons. I'm still pressing a lot of buttons, but I don't have to press nearly as many. This is about 3.91 inches, feet, miles, yards, whatever that label would be. Make sure as you're doing these problems, your capital letters all end up with degree symbols and your lowercase letters all end up with the appropriate label. And these problems, I'm not giving you a label, so I'm not too worried about it. But you are finding a distance, a length. For all of these, you should be able to go back and verify using your triangle inequality and your hinge theorem and all that fun stuff that the longest side is across from the longest angle, or the largest angle. The smallest side is across from the smallest angle. There is your assignment, 1 to 19 odd. You might have some in there where you have a bunch of work, like the one we just did, and you might have some that have hardly any work, kind of like number 3, where it's just, hey, this triangle can't exist. Make sure you bring questions to class, and I hope everybody has a great day.